Hi, I'm Aditya Singh, and this video is a demonstration of a project I made for the Clever AI program titled FEMR, a facial expression music recommender. It is an application that recommends songs to users based on their facial expression. Now, before we move on, I would like to thank Mr. Ken Khan, who is a senior researcher at Oxford University, and the Clever team for mentoring me throughout the project. I would also like to thank Clever for designing the AIIP program. It's a wonderful program if you want to learn the basics of deep learning. And what's special about AIIP is that teaches you by making you do real data sets. So you basically solve real data sets, and that is how you learn. And that really reinforces the concepts. Now, more about FEMR. The way the app works is that takes certain frames from your webcam feed, and for each frame, it extracts faces using the har cascade library. The faces are converted into a 48 by 48 grayscale, and then passed through a convolutional neural network or the CNN model, which labels it as follows. It's either going to be anger, disgust, fear, happiness, sadness, surprise, or neutral. Then, for all frames, these facial expressions are averaged out, and based on this average, the songs are recommended. Now, the average works like this. So, for each image P, which is basically a NumPy matrix, 48 by 48, the model gives out a prediction, and actually, the predictions are an array of like seven values, which are probabilities for each of these expressions. So, we take the maximum index of the maximum probability, and then we multiply it into by the frame number. So it's like a weighted sum, and the later frames are given more weight than the previous frames, and all these frames are then averaged out. So it's basically like a weighted mean, a weighted arithmetic mean for all the facial expressions, and according to it, the songs are recommended. Now, here's the structure for the CNN. You can see that there's a convolutional layers going from 64 all the way to 256, and then each has a batch normalization and uh, followed by pooling, and these the resultant output is then flattened out, and it's passed through the fully connected layer, and finally we get the output. So this model has been trained on the for 2013 data set, and after 10 epochs or so, it achieved an accuracy of 80.21% on the training set and 78.13% on the test set. It's pretty good. Did take a lot of time, but it's pretty good for that. And now let's talk about the UI and how to use Funnel. So the way FEMA works is that once you press the scan button, it starts taking your webcam feed, and once it's done scanning your face, you can it will display the song names. And now that's the introductory part. If you have any suggestions or concerns regarding the app, you can contact me at aditya.rsingh333 at the rate gmail.com. Now I'll show you how the app works. So if I run this part here, you can see that this window has appeared telling me to scan, and once I scan, so it detects the face and gives the neutral uh, expression. So that's correct. Face expression is neutral, and accordingly it has given you songs. And if I smile in the camera, it will give a happy output. Accordingly it will give you these songs. So now I'll walk you through the code. What happens is that I've separated songs into these CSV files. So for happy, you have certain songs, and for each expression, you have certain songs. These songs are loaded into this dictionary, and we also use these labels, which their position is what is outputted by the model prediction, and that is converted into these text labels that are helpful for users to see. So once we're done loading the dictionary, we use this function to do the entire scanning procedure. So, firstly, How the CNN works is that this function basically gives the output of the CNN. So we load the har cascade library and then we start the cam. And for each frame of the webcam, convert it into a grayscale image and extract the faces using the har cascade. And the har cascade will output X, Y, and the width and height of face in the image space. And for these coordinates, what we do is we firstly we construct a green rectangular frame around the face so that the user knows that his face is being scanned correctly. And then the faces are we take the x, y, and wh coordinates and pull out the face. So it's like cutting out a square out of a larger square. This is reshaped according to the input of the CNN and divided by 255. So it's scaled, and that helps with the performance of the network. The weighted sum is calculated as we had seen in the slides, and they're averaged out, and this average is returned. So this is the output of the CNN. Now, once we get the average from here, which is spread, we find the mood using the lookups, and then use this playlist function, which it will give you for any look list you pass. It will give you 10 random elements from that list. So you we get 10 random songs from any CSV depending on the mood, and then we display the CSV as the songs from the CSV, as you can see here. So that was FEMR. It was a fun project to make, and hope you enjoyed this video. This is Aditya Singh, and thank you for your time.